All right. Good evening, everyone. I hope you had a wonderful heritage holiday. We are back to school now. We want to finalize our topic on Loci and in particular the Helix. But today we are going to focus mainly on the coil spring. Some would call it a round spring. Let's look at what it entails with regards to definition. Like I said, our content today is on the loci, right, and the helix in particular. Then we want to look at the application of the helix. We've looked at so many applications this far. We looked at the auger, we looked at the chute, we looked at the square spring, we also looked at the thread. Now we are focusing on the coil springs. By definition, a coil spring is a mechanical device which is typically used to store energy and subsequently release it to absorb shock or to maintain a force between conducting forces. They are made of elastic material formed into the shape of a helix, which returns to its natural length when unloaded. Right, so if you would check with regards to the definition, the concept of a helix is continuously coming in. That means we are still making use of the helix. So these are applications of the helix. Under tension or compression, the material, which is the wire of a coil spring, undergoes torsion, right? That is twisting. The spring characteristics therefore depend on the shear modulus, not the Young's modulus. Right, a coil spring may also be used as a torsion spring. In this case, the spring as a whole is subjected to torsion about its helical axis. The material of the spring is thereby subjected to a bending moment. Right, some of these terms I would leave the discussion for another day, right? Either reducing or increasing the helical radius. In this mode, it is the Young's modulus of the material that determines the spring characteristics. Now, once we have got the background like this, we know, right, if you are looking at a spring, it either can be stretched or it can be compressed or it can be twisted. But the most important thing is that the quality of that spring should be able to withstand the forces which are acting on it, whether it is tensile, whether it is compressive, whether it is torsional forces. The spring should be able to counter those effects in terms of the forces. Right, let us look now at the construction of the round spring. Remember, basically it's coming from the concept of a helix. So we want now to look at the construction. But before we look at that, right, remember, I hear and I forget, I see and I remember. I want you to make sure that you pay attention and see everything that we are doing. Just mere hearing about what we are talking about would not help you much. But most importantly, I want you to do it in order to understand it. Okay, let's go straight to the construction part of this and enjoy the lesson. Right, so what we have, right, we have got the given information. We are going to make use of this diagram as well as that diagram, okay, separately. There you go. Right, the top view of a round spring showing the starting point or position, right? The starting position would be this part, which is a straight line like that. But also we are also given the starting position in terms of where we are going to draw the top view. Remember, this is in third angle orthographic projection. So we have got the top view at the top and the front view at the bottom. Then we have got the specifications, the right hand, right? If we check with regards to the right hand, just focus that here, okay? Right, the right hand direction, it's right-handed direction. Then the number of turns is 2, right? And also starting at the bottom, the spring profile diameter, right? I just want to change this diameter, right? What we are given now is 8, but I want it to be 12 so that it's slightly bigger than here, okay? Right, so the diameter should be 12 in terms of the spring profile. Right, the pitch is 48. Remember, the pitch is the length from one point to another similar point of the next revolution. We regard to that one as the pitch, the longitudinal distance between one point and another similar point. So if you start from point 0 to another point 0, that distance is regarded as the pitch. Remember, we said the spring profile, we are going to change that. Right, starting at the start position, draw to scale 1:1, the front view and the top view of the round spring, right? The round spring can also be referred to as the coil spring. Show all necessary constructions, no hidden detail is required, okay? Right, so we are going to do the right hand spring, then on the right hand side, we are also going to look at the left hand, but the constructions will basically be the same. Right, then the other thing, right, we want also to look at, we are also going to change this size. It's diameter 68 here. I'm going to change it to diameter 74, such that if we look at the size, 74 minus diameter 76, sorry, right, 76, diameter 76 minus diameter 52, we are going to have 24. But the 24 is shared between this one and that one. So either side, it will be 12 and 12, okay? Right, so if it is diameter 76, okay? Right, so we are going to say diameter 76 divided by 2, which means radius 38, okay? I'm going to draw a faint horizontal line like that. And a faint vertical line like that. There you go, measure 38. Right, this is what we refer to as the nominal diameter or the maximum diameter or the outside diameter. Draw a circle. Okay. Right, then we have got the minimum diameter, which is also the inside diameter. Right, it's 52, which means radius 26. Let's just check. This should give us 12, which is exactly 12 like that. Right, then we draw another circle. Radius 26. There you go. Okay. Then we project this one going down. okay? Right, these two lines, they are basically there for guiding. What we require basically is the center line. Right, we know that the distance from here to there is 12, so we need 6 millimeters, which is the center line, okay? That is if we are drawing the PCD, which is actually it. Then we draw. So this is the center line, which is in form of a circle. We refer to that one as a pitch circle diameter. Right, okay. So now that we have got this, right, this, if we draw a circle, it should assume a diameter of 12, okay? All right, now we are also given the pitch, right? And we have got 2 turns, right? What it means, we need to multiply the pitch times 2, right? In this case, the pitch is 48, so it's 48 times 2, which is 96. Right, let's see if we can get a height of 96. Take this one up slightly. This point. And that point. Missed it just a little bit. There you go. Okay. Right. So from here to there, that's 96. Then I project this one down. Also this one down. Divide this one into 12 equal parts, the center line. That is the key part. So I'm going to just do this. But the part that I'm going to use is the center line. We've got this. Project this one down. From the center line, just erase this part off slightly. Right, that's right. The other divisions are already there. Right, then we also divide the height into 12 equal parts, right, for 1 turn. But if it's now going to be 2 turns, we are going to divide this one into 24. So I'm going to mark here. Right, like that. Let's verify. Like that, okay. Right. Remember, you could still find that it's 96 divided by 24, right? Which means you need 4 millimeter, 4 millimeter, 4 millimeter divisions like that. But in some cases, you find that there is a mark for showing these divisions. So instead of measuring 4, 4, 4, 4, 4, 4, we want you to find those divisions graphically, okay? Which means by construction. You project to the other end. These are the horizontal divisions. There you go. Right, okay. Now, we are also told that in terms of the helix itself is starting at the bottom, right? So we are going to label, this is point 0, then 1, 2, 3, 4, 5, 6, which is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 0. That's a pitch. Then 1, 2, 3, 4, 5, 6, which is here. 7, 8, 9, 10, 11, 0, which is there. That's a second pitch. So if you measure from here to there, you'd find 48. From here to there, you would also find another 48. Right, then we have got this is our 0, okay? Right, it's a right-handed, which means it's clockwise. But because it's starting at the bottom, we are going to number anti-clockwise. That's our point 1, that's 3, that's 6, and that's 9, okay? Right, in an anti-clockwise direction to oppose the given hand. But if it was starting at the top, we're going to say number 1, number 2, number 3, and so forth, okay? Right, now, if we project, this is point 0, right, which is here, okay? Now, you take your canvas again, right? You take the radius, but before you do that, you need 0, that's point, right? This is 0, which is here. we are only going to consider the points which are coming from the center line, which is our PCD, right? So it's 0, then that's 0.1, right? Then 0.2, 3, 4, right? 5, and 6, 7, 8, 9, 10, 11, then 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 0. Okay, right. Either way, if we start here, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0. That is one complete 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0. That is the second 10. Right. You are going to connect this one, right, like that. Right. So this is the helix of the center line, okay? Right, I'm going to define this one properly in terms of the center line so that it shows as a center line as well. So I'm going to do this. That's the center line. Right, okay. So this is the center line, right? From here to there, that's the helix of the center line. Then once you have done that, you now take the size in terms of the diameter of the spring itself. In this case, it will be radius 6 millimeters. So at each and every point, you draw a circle to represent that. Right. In some case, you may not even need to draw a complete circle. So that's the first one. Just take this one. Right. So I go to point number 1, which is here. Like that. Then point number 2. Not outlined, just for construction purposes. Point number 3. at each and every point, right, on the center line. Sorry. Nothing is outlined at this point. There you go. Okay. Now, the next thing, right, once you have done this, right, the next thing that you will need to do is to draw a tangential line touching each and every circle. Like that. Do the same this side. That. There you go. Now, what is key now is how you are going to outline in terms of the construction, right? How you are going to outline, right? Remember, we are saying it's right-handed. So I'm going to outline, right, up to the center line for the first one, which is going to the right. So I'm going to do this. Stop there. Right, you do the same this side. Like that. Look for another right-handed, going to the right. You do this. Like that. Then this one, which is going to the left, right? If you are checking for the particular hand, right, you would see if I follow this one like that, it is going to go beyond this line, which is coming from this side. So that loop here, which overlaps this one, is the one which determines the hand, okay? Right, if it was left-handed, this one was going to come like that, and this one is stopped here, right? This one, because it's right-handed, it's going to meet the center line and all the way it negotiates like that. So I'm going to also outline this one. like that. Then it is stopped here. Right, so this connection between this line and that line is the one which defines the end, okay? Right, there I'm not going to start here, I'm going to start there because this already has been defined as going to the right, so I'm going to start from here. Then we do the same. Like that. What it means, therefore, now, right, if you look at this one, which is going to the right, you can easily close this, close that with the canvas. Then the other one, which is showing, which is here, now it shows you the face, so you outline this because it's not going to face down, okay? Right, you outline that face. Right, once we have outlined that face, we need now to show hatching lines. Show hatching lines here. Like that. There you go. Right. So we now have got a round spring, right, which is right-handed, which is 2 turns, which means 2 revolutions. Right. Now this loop and that one, as well as that one, it shows you or it defines the hand. Okay. If it is the other way around, if this one was going to come here and this one stopped there, you would automatically know that is left hand. Right, so the left hand, the right hand, it's basically the same in terms of how it would appear, except for that small little loop, okay? Right, let us look at the left hand and see how it would differ with the right hand in terms of the ultimate view that we'll be able to see. Right, we are not going to do much in terms of construction. We are simply going to take the same constructions and transfer them to this side because the specifications are the same. Like we said, we are going to change this, right, to diameter 76, and we are also going to change the size in terms of the profile to diameter 12, like that, okay? Right, so the size in terms of the distance from here to there is 12, from here to there it's also 12. By virtue of this being the section that we are able to see, that's why you find that there is an edge which we are able to see. So that is how you go about with regards to a round or a coil spring. Right, it's not difficult, right? You just need to follow the principles, right? In most cases, you find that in your paper 2, you either have got something like this, plus maybe the chem, right? So it also could be combined with the mechanisms, right? So you need to understand this so that you can answer this question with confidence, okay? Like I said, I'm not going to change the specifications. Let me just use these ones, which are there. Right. Take this one, focus it slightly a bit. I'm going to do this project faintly and do the same here, like that. Take the specifications from here, which is 26. I'm going to draw circle 26. Then the other one, radius 30, 38, which is from here to there. Right. Then also find the sender, which is 26 plus 6, which is radius 32. This one is defined as the center line as well. There you go. Okay. Right. This time we don't want to divide or project downwards the other lines. We just want to focus on this, which is the center line, because that's what we want. Project this one down. Then take the divisions from here. Let me just project the first one and the last one so that you see the link, okay? But I'm just taking from here. Like that. Then bring these lines down faintly from the center line. I need to go back to the first one, but I missed something. Center line. Here it's outlined and center line like that. We'll also do the same this side. Center line. There you go. Okay. Right. So we have got the center lines, then center lines, and also center lines there. Now, the next thing that we need to do, right? Let's check. Where is it starting? It's starting at the bottom, right? Which means, right, it's still on the left-hand side. So we still have got coil 0 here. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is pitch, 1 pitch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is the second pitch. Okay. Right. Remember, you don't need to show the labels if you want, but as you can see, these are very important in terms of determining our diagram. Okay, right. Should have brought this one just to guide us. There we go. Right, so this is point 0, 1. Right, this is also our point 0. It's left-handed. Right, so now it should, if it is starting at the bottom, it should be going up, right, in a clockwise direction to counter the rotation. So 6 and 9, okay? So we have got 0, 1, 2, 3, 4, 5, 6, 9, back to 11, okay? Right, so that's 1, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0, 1, 2, 3, 4, 5, 6. There you go. Okay. Right. Then you join these points to create the center line. Friendly face. There you go. So you have got the helix, right? This is the helix of the center line, right? Or the point which is in the middle, which basically is our center line. We have got that one as well. Right. We can define this one. We can define, let me just show it using a red pen. It is not so clear. There you go. Right, so that is the helix, which is for the center line. Then the next thing, right, we take the radius in terms of the section of the spring, which is radius 6. Something like this. Right, at each and every point, we define like that. Define the section, but we don't outline at this point. It's just construction line. Sorry. No need to draw a complete circle, but remember we shall draw a tangential line, a line that will simply touch those circles without getting into them. Right, there you go. Right, so at each and every point, you connect or you draw circles which are representative of the section of that spring profile. Then from there, you draw a tangential line touching the circles. But not getting into the circles, you do the same. To the center line. Right, I will start also from here. Like that. The next one is going to the right. Like that. There you go. Okay. Right. Once you have done that, you can now outline, start by outline that helix or part of the helix which is going to the left. Start with this one. When you outline now, you can now correct even the small errors that you would have made with the faint construction line. All the way to the center line like that. That is the loop that we talked about earlier on. Here, not so defined. Right, like that. The loop. Then you focus on the one which is going to the right. Stopped by the loop. Here we go. Stopped by that. There you go. Right, okay. Now, this is closing like that, which is closing like that. This is exposing this part, right? So this one is closing, right? So we are going to outline this part. This one. And also just close that part like that. But this is exposed, so we are going to show hatching lines like that as H in the different direction. Like that. Now, if you check, if you compare the two springs, right, this one is going to the left, so you find the loop is to the center line, and the loop is to the center line, the loop is to the center line. Whereas if you check with the right hand helix or spring, if the loop is going to the center line, which is the right one, right? The one in the inside, right? The one on the outside, right? So this is the part which defines the hand, okay? Right, left hand going to the left, going to the left, and this one stopped, which means it's not going all the way to the center line. So this one is left hand, this one is right hand. But if you look at that in terms of how they would appear, it's almost, they are looking basically the same. What would define the difference is just these loops, okay? The other one, which would extend to the center line, 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 like that. That is the only difference. So here it is. This is how you go about drawing the helix, which defines the round spring, or which can also be referred to as the coil spring. Now we have reached the end of our discussion in terms of the helix, okay? Like I said, we started with the helix itself, from a transparent cylinder to a non-transparent cylinder, such that you'll be able to define, right, the path, which we refer to as the locus. Remember, plural for that, it's loci, okay? Right, so we were able to define the path, which is the locus, for a transparent and a non-transparent. Then we looked at the auger, okay, which we say is more of the definition of a drilling bit, something that is to cut something. It could be wood, it could be metal, it could be ice, anything that would need, is used for boring or for creating a hole. Right, then we also looked at a chute, okay, right, which we gave an example of a slide at a park, right, for our recreational purposes. And we also talked about a water chute, right, also at recreations and funny purposes. Then from there, we looked at a square spring, okay? Today, we looked at a round spring, but then we started with a square spring. Then from there, we looked at the thread. Now, we have looked at the round spring. So these are the main applications of the concept of a helix that you need to know, that you need to understand in EGD. I hope you enjoyed this, and hopefully you should be able to apply this concept on your own and master it. Have a good night and goodbye.